Okay, as I discussed before, the goal is that we do like very many lessons and then try to get our work done during our Zoom calls, and after our Zoom calls, hopefully have a little bit of extra free time once we're done with our assignment. So for that to happen, I will be creating videos like this one, videos that you can watch on your own time, especially like for students that are absent. Those will be accessible at all times. And then for those of you that just need that extra help or introductory. So these will be required. You should be watching them before coming to class. This is the first one, so this one we're going to do in class. And then we'll discuss any problems or questions that come from it. But the goal will be that this will be like technically your homework along with some practice problems. And then we come to class the next day and we work on our assignment for the day. And we can kind of like ask questions as we go along. Okay, so first things first, we're talking about prime factorization today. So prime factorization is going to be the title of our lesson. But first we have to talk about a couple things. So prime numbers are numbers that can only be multiplied by 1 and itself. Examples of that are 2, 3, 5, 7. Can you think of one other prime number? And then we have composite numbers. Composite numbers are basically made up of prime numbers. So every single composite number starts by being created or being multiplied with other prime numbers. So for example, 4 is the first composite number starting from 1. So 1, 2, and 3, or 1 technically is not prime, but 2 and 3 are prime numbers. 4 is the first composite one, and that comes from 2 times 2. Then 5 is prime, and then the next one is 6. 6 comes from multiplying 2 times 3. And then 7 is prime, and 8 is composite, and that comes from 2 times 2 times 2. And the list goes on. So what this is showing us is that all composite numbers can be brought back to a list of prime numbers. And so that's basically what we're doing today. We are creating that list of prime numbers that make up our composite numbers. Okay, so I do want to point out a few things. These definitions. So as we talked after the warm-up, factors are the numbers you multiply together to get another number. So factors and multiplication, you should always be thinking of them together. So factors are anything that multiplies to get another number. They don't have to be prime factors. They just have to be multiplying to get that number. So factors of 6 are 2 and 3. If, let's say we had 18, factors of 18 could be 6 times 3. That's a factor. And that's a factor because of the simple fact that they are multiplying together. They're not prime factors though. Only 3 is a prime factor. So prime factorization is finding which prime numbers multiply together to make the original number. So even though I can get 6 times 3, I want to know what prime numbers get me that 18 so I can keep breaking it down. So what I would do in this case would be like once I have 6 and 3, I would keep breaking it down. So this one we said was already prime, and then we would see what prime numbers make up 6, because if I can find that, then that's the same as 6 times 3. So 2 and 3. That's prime, that's prime. So the prime numbers that make up 18 would be 2 times 3 times 3. This replaces my 6. And my 3 was already prime. Okay, and then moving on, now I want to go over just a few examples. So that was the definition. So when we're working with the prime factorization of 12, what they're doing is they're starting to work with the smallest prime number. So you want to find the smallest prime number that is a factor of 12. In this case, when we say that, we mean what number can I divide 12 by? Remember that a factor, since it multiplies to be that number, you can also divide by one of the factors because they go hand in hand. So I'm going to do on the side something I call like backwards or upside down division. So if we're starting with 12, the smallest prime number that can go into it is 2. That's the smallest prime number that can go into it. And then from there, once I divide 12 by 2, I get 6. And then I can keep going. So what's the smallest prime number that goes into 6? 2. And then 6 divided by 2 is 3. So then that's the number that I have left. What's the smallest prime number that can go into 3? Well, actually, it's just itself. So 3. And then 3 divided by 3 is 1. Once we get to 1, we are done. So I call this upside down division because usually we divide like this, get our answer up here. So then I'm just kind of creating a list of prime numbers by flipping the way of writing that. And then I can clearly see that the prime numbers that make up my 12 are 2, 2, and 3, which is exactly what they have written here. So that's one method of finding all your prime numbers. Now, here, remember that it said what is the smallest prime number that goes into the number. So here it says can we divide 147 exactly by 2? So 2 is the smallest prime number, but is it the smallest prime number that goes into 147? That's the key word or key idea. So 147 divided by 2 gives us it's technically a decimal or a fraction or just basically not a whole number. So 73.5. No, it cannot. It cannot be divided by 2 because it doesn't give me a whole number, which means 2 is not a factor of 147. So then you try the next one. So can we try 3? 147 divided by 3 is 49. And you can just do division on the side for yourself. So like you would do 147 divided by 3. 3 goes into 14 4 times minus 12. Then we have 27. 3 goes into 27 9 times. And that's how you would get 49. So you might have to do a little bit of extra work, but it should get easier as you work with it. Now we need to factor 49. So see if obviously 2 can't go into it because if it didn't go into 147, it's not going to go into 49. We can try 3 again, but if you try that, it's actually not going to work out. So let's try 5. 5 is the next one. That's not divisible by 5 because it doesn't end in 0 or 5. And then the next one we try would be 7. So then here, 7, 49 divided by 7 would be 7. And then the only prime number that goes into 7 is itself. So 7 divided by 7 is 1. And then I have my list of prime numbers right here. 3, 7, 7. Which is exactly the answer that they got right here. Okay. And then we'll talk about using exponents. It should be relatively easy. Anytime you see the same number, you can just use exponents to shorten it. So you don't have to write 7 2 times. You could just write 7 squared. And then once we get to those longer ones, you might have like 8 2's and you don't want to write out 8 2's, so you're going to do 2 to the 8th power. Okay, next. Sometimes you might get questions that say, what is the prime factorization of some number like 17? But then you have to realize that 17 is actually a prime number. I will try to give you that chart from 0 or from 1 to 100 that identifies the prime numbers. All right. And so here's the other method of finding these prime factors. It's called a factor tree. So a factor tree, you start with the number, like they did here, 48, and you break it down into factors that you know already. So if you don't know that 2 can go into 48, that's fine. If you don't know that 3 can go into 48, that's fine. But if you know that at least 8 and 6 go into it, then that's where you start. So what they did is they started at 48. They said factors of 48 are 8 and 6. However, we're doing prime factorization, and 8 and 6 are both not prime numbers, which means I should be able to keep breaking them down because all composite numbers are made up of prime numbers. So until I get prime numbers, I'm not done. And then we break down 8 into what we know is 4 and 2. And then once you get a prime number, you might want to circle it or underline it so that you don't forget it. And then we can keep going with 4. 4 can be broken down to 2 times 2. And then those are both prime numbers, so I highlight them or circle them or whatever I need to do. 6 is still not broken down, so I need to break it down just a little bit more. I know that I can multiply 2 times 3. 2 is prime. 3 is also prime. I have no more, like I can't break that down. I can't break this down. None of these because they're all prime. So once I have all prime numbers, I am done. And then you just write them all together. So we have 2 times 2 times 2 times 2. Here's my 4 2's. And then times 3. I like doing the underlining just because it kind of like gives me like a nice stopper. So when I don't have the underline, I know I can keep breaking it down. And then as we talked about, when you have a bunch of 2's, you can write them as 2 to the 4th power because that's exactly what exponent means. And then just the 3 was by itself, so just times 3. Okay, so we'll do one quick example just because this video was just slightly longer than I was wanting it to be. But we're just going to do a somewhat of a big example. Not really, but 160. So 160, again, you have to start by what you know. If the only thing you know is that, hey, that's an even number, that's fine. You can start with 2 times something. But I'm going to start with the fact that if it ends in 0, it's divisible by 10. So 10 times 16. And see right away, now I have easier numbers to work with. My 10 is not prime, so I can keep breaking it down into 2 times 5. And then right there, I have a prime number here and a prime number here. Now, what about 16? 16, I could do 4 times 4. If you didn't think of 4 times 4 and you thought of 8 times 2, that's fine as well. And then my 4, I can break down into 2 times 2. Same thing with the other 4. You need to make sure that for every single number, you are getting 2 factors. And once they're prime, you're underlining them or circling them. Okay. And then so like one thing that I don't want you to get confused on is the reason why we don't use this number anymore is because I'm breaking it down. 10 times 16 is 160. So when I do this, they are equal. So as long as I do something that equals 10 and something that equals 16, I haven't changed anything. If I multiply it all again, I'm going to get 160. So to replace my 10, I do 2 times 5. I haven't changed the number. I still have 10. Same thing with 16. If I do 4 times 4, I haven't changed the number. I still have 16. And 10 times 16 is still 160. And if I keep breaking it down, again, I'm not changing anything. This is 10. This is 4. And this is 4. So that's 4, that's 4. 4 times 4 is still 16. I still have 10 and 16 here, which multiply to be 160. So just keep that in mind, that when you're breaking stuff down, you're not changing anything. I have people that still want to use, like, they want to go back and use like 10 or 16 or 4, and those are not usable anymore. You broke them down, you rewrote them. So this is 10. This is still 10. This is still 10, just represented in a different way. This is 16. That is also 16. That is also 16. And again, 10 times 16 brings you right back to 160. So keep that in mind. And when we write all of this, we typically want to write it in order. So our 2's go first. And there was 5 of them. And then our 5 goes at the end. If I had any 3's, they would go after the 2's. And then I can write my 2's as 2 to the 5th power, because there's 2 of them. Or sorry, 5 of them. And 2 to the 5th power times 5. There we are. Okay, so hopefully that helped. Your entire assignment today will be on prime factorization with like 2 to 3 questions review from yesterday. So if you have any questions, make sure you're reaching out.